I'm explaining HalvingRandomSearchCV, a hyperparameter tuning technique in machine learning. It's like a race where we start with many options and gradually eliminate the weaker ones. We begin with 3 key settings. N_candidates the number of initial options. Factor how many times we shrink the options. And min_resources the minimum data needed to test an option. I have 81 initial options. I'll reduce them by a factor of 3 at each step, and the minimum data needed per option will be determined automatically. I'll test all 81 options in the first round. This is the first round of testing. I'll evaluate each of the 81 initial options. After the first iteration, I'll choose the top 1/3, which is 81 divided by 3 equals 27. I keep only the top 27 best performing options from the previous round. For the next round, I'll select the best performing 1/3 of the remaining options, which is 27 divided by 3 equals 9. I narrow it down further, keeping only the top 9. I proceed to the next step selecting the best performing 1/3. This time it's 9 divided by 3 equals 3. I'm down to the top 3 options now. For this final round, I choose the best performing 1/3. 3 divided by 3 equals 1. I've completed the entire process, and 5 rounds of testing were needed to find the best option. I'm setting up the hyperparameter tuning process using HalvingRandomSearchCV. I'm starting with 81 candidate sets of hyperparameters, a reduction factor of 3, meaning I'll keep only 1/3 of the best performing candidates at each step, and letting the algorithm automatically determine the minimum resources needed. This is the 4th round of evaluation. I've already reduced the number of candidates 3 times. Now, I only evaluate the top 3 candidates from the previous iteration. This is the final round. I've narrowed it down to only 1 candidate remaining from the previous step. Now, I evaluate that single candidate to find the best hyperparameter setting. At this point in the process, I've already eliminated 2/3 of the initial candidates. Now, I evaluate only the top 9 candidates that performed best. I now evaluate only the top 27 candidates from the first round. The top 1/3 of the previous round is selected. I am getting closer to the best settings. This is the first evaluation round. I start by evaluating all 81 initial candidates. In the first iteration, I'll thoroughly evaluate each of the 81 candidates to get a good sense of their performance. This is the most computationally expensive step. After all the iterations, I've pinpointed the single best hyperparameter candidate set. It's a much more efficient way to optimize my model than evaluating all possible candidates individually. Awesome! I'm tuning hyperparameters using HalvingRandomSearchCV, a technique that efficiently explores a large hyperparameter space. It's like a smart search that progressively focuses on the most promising areas. We start with 81 different sets of hyperparameters to test. Think of it as having 81 different recipes for your model. We need to test which one works best. After the first round of testing all 81, I keep only the top 1/3, 27, performing candidates. We're getting rid of the worst performing recipes to speed up the process. After the 3rd round, I've narrowed it down to only the top 3 candidates. It's like a culinary competition. We are only tasting the top 3 dishes. Finally, I have a single winner, the best performing set of hyperparameters out of the initial 81. The winning recipe is identified. After the 2nd round, only the top 1/3, 9, are left. We are only interested in the top contenders. In the first iteration, I evaluate all 81 initial candidates. It's the initial tasting where we try all recipes. I'm sorry, but this is not part of the text provided. Therefore, I cannot elaborate on it. Because I divide the number of candidates by 3 at each iteration, factor equals 3, I'll have 5 iterations before ending up with only 1 candidate. This is analogous to repeatedly having something until you are left with a single item. I set min_resources equals auto. This automatically determines the minimum number of training samples. It's like the algorithm deciding the minimum amount of ingredients needed based on the recipe's complexity. This statement is actually false. My calculation shows that the final iteration will only have 1 candidate. The final iteration tests the best single model to choose. In the first iteration, all 81 candidates are evaluated, a comprehensive initial screening. I'm looking at the HalvingRandomSearchCV process. It's a method for tuning hyperparameters, which are settings that control a machine learning model's behavior. It's like systematically trying different settings to find the best combination. We start with 81 different sets of hyperparameters. Think of it like having 81 recipes for our machine learning model. We'll test each one initially. This is our first round of testing. I'll try out all 81 hyperparameter combinations. In this first round, each of the 81 hyperparameter sets is used to train and evaluate the random forest classifier model. We're assessing their performance on a dataset. After evaluating the 81 candidates, we've ranked them based on their performance. Now, I'm only moving forward with the top 1/3, 27 candidates. We're discarding the bottom 2/3 based on their poor performance. I'm only keeping the best 27. Think of it as eliminating the worst performing recipes to focus on more promising ones. Let's repeat the evaluation process with the 27 remaining candidates. Again, we're only keeping the top 1/3, the 9 best performing sets of hyperparameters. Once again, the process repeats itself. I am evaluating the 9 candidates. We're down to the top 3 performing sets of hyperparameters now. In this last round, I'm evaluating the 3 candidates. Finally, after 5 iterations, we're left with only 1 candidate, representing the best performing set of hyperparameters. Yay! This is our winner, the optimal set of hyperparameters found through this iterative process. We start with 81 candidate models. That's our initial pool of hyperparameter combinations to test. Think of each candidate as a unique recipe for your random forest classifier. This setting dictates how aggressively we cut down the number of candidates in each iteration. A factor of 3 means that after evaluating all the candidates, I only keep the top 1/3 for the next round. I'm ruthlessly eliminating the underperformers. Setting min_resources to auto means that I let scikit-learn automatically determine the minimum amount of data, like training samples, needed to evaluate each candidate model. It's a smart way to avoid wasting resources on very small datasets. This is the algorithm that I'm using to cleverly search for optimal hyperparameters. The halving part refers to the gradual reduction of candidates in each iteration, like a tournament where the worst performers are eliminated. The random search aspect means I'm randomly selecting the candidates instead of doing an exhaustive search. In the first round, I evaluate all 81 models to see how they perform. This is the most expensive iteration in terms of computational cost. After round 1, I keep only the top 1/3, 27, of the candidates. The others are discarded because they didn't perform as well. I repeat the process. Now, only the top 1/3, 9, of the models from the previous iteration are kept. We're getting closer to the best model. I now keep only the top 3. Finally, only 1 model remains. This is my best performing model, identified after several iterations of rigorous elimination. I'm setting the factor to 3. This means that after evaluating candidates, I'll only keep the top 1/3 for the next round. It's like a survivalofthefittest competition. I'm starting with 81 candidate sets of hyperparameters. This is my initial pool of options to test. I'm letting scikit-learn automatically decide the minimum amount of data to use when evaluating each candidate. This is handy because it saves me from making that decision manually, and it is smart enough to adapt to the dataset size. I'll start by testing all 81 candidates. After the first round, I'll reduce the number of candidates from 81 to 27 by keeping only the top 1/3, 81 divided by 3. Again, I'll reduce the candidates to the top 9, 27 divided by 3. I'll further refine my search to only 3 candidates, 9 divided by 3. Finally, I'm left with only 1 candidate after keeping the top 1/3, 3 divided by 3. I'm setting up the hyperparameter search using HalvingRandomSearchCV. I'll start with 81 candidate parameter combinations, reduce that number by a factor of 3 after each iteration, and let the algorithm automatically decide the minimum data needed for each evaluation. In the first round, I'll evaluate all 81 candidate parameter combinations. This is what I mean by the first iteration. I'm evaluating every single one of those 81 initial candidates. After the first iteration, I select the top 1/3, which is 27 candidates, to move on to the next round. I'm keeping only the top 27 performing candidates from those initial 81. This is a third, 1/3, of 81. Next, I'll take the top 1/3 from iteration 2's results. This is 9 candidates. I take the best 9 out of those 27. I repeat the process. From the top 9 I select the top 3. Only the top 3 candidates from the previous step are moving on. In the final iteration, I'll select the top 1/3 of the remaining candidates. That leaves me with just one candidate. So, I have a total of 5 iterations, resulting in one final candidate that will be used to train my model. Pretty cool, huh?